We're living in the age of AI, right? And we spend all our time obsessing over GPUs, these incredible engines driving the revolution. But here's the thing. There's a secret bottleneck, a massive hidden traffic jam happening inside our data centers that is literally throttling AI's true potential. And the race to solve it is creating a completely new kind of network. So let me just ask you this straight up. You've probably invested a ton of money in the fastest GPUs on the planet, but are they spending most of their time just waiting? It's probably the most critical question for anyone building out AI infrastructure today. Because look, if your GPUs are just sitting there idle, you're not just losing performance, you are actively burning cash. All right, so before we get to the solution, we've got to understand what's actually broken. And the honest truth is, the way AI models communicate, it doesn't just bend the old networks we've been using for decades, it absolutely shatters them. Think about it like this. For years, network traffic was basically like cars on a highway, pretty predictable, pretty orderly. But AI traffic, it is not a highway, it is a flash mob. It's what we call east-west communication, where every single GPU needs to shout enormous amounts of data to every other GPU, all at the exact same time. Traditional networks, they were just never designed for that kind of chaotic, synchronized chaos. So what happens when you try to force that AI flash mob onto a traditional Ethernet highway? Well, you get a complete system-wide pileup. Latency just spikes through the roof, some of your GPUs get starved for data while others are hogging all the bandwidth. And if you're in a shared environment, just one massive AI training job can bring everybody else to a grinding halt. It's just the wrong tool for the job, simple as that. So, okay, if the old roads can't handle the new traffic, you don't just add more lanes, right? No, you have to redesign the entire transportation system from the ground up. And that is exactly what NVIDIA has done with its Spectrum-X platform. Now, the really crucial thing to get here is that Spectrum-X is not just a faster switch. It's a complete end-to-end platform. We're talking about an AI fabric where the switch, the super advanced network card, which they call the Super NIC, and all the software, they are all co-designed to work together as one single intelligent system. It was built from day one just for AI. And here's a look at how it actually works. At the very center, you've got the Spectrum-4 switch, and it's acting like the master traffic controller. But the real magic, the secret sauce, is how tightly it coordinates with the Bluefield-3 Super NICs that are inside every single server. These aren't just passive parts anymore. They are active partners in managing the data flow, which makes the entire network fabric smart. This whole system is what enables something amazing called adaptive routing. So here's how it works. First, instead of trying to shove all the data down one potentially clogged path, the switch literally sprays the data packets across tons of different routes. Then, the fabric intelligently guides those packets along the paths with the least traffic in real time. Now, this means they arrive completely out of order, which, by the way, would absolutely cripple a normal network. But that brings us to step 3. The Bluefield-3 Super NIC at the other end instantly reassembles everything in hardware before it even gets to the GPU. The result? You get near-perfect performance with basically no congestion. It's brilliant. So, what does all that clever engineering actually get you in the real world? It gets you this, a staggering 1.7 times improvement in overall AI performance compared to old-school Ethernet. I mean, think about that. That means your models train faster, inference is more efficient, and you get a much, much better return on your entire GPU investment. Now, a performance leap like that doesn't just happen in a bubble. For this technology to actually get out there and reach the enterprise, it needs a whole ecosystem. And that's exactly where a networking giant like Cisco comes into the picture, because they are fully embracing this new fabric-centric way of thinking. And this quote from NVIDIA's head of networking really frames the whole partnership perfectly. This isn't about competition. It's a really deep collaboration. The whole goal is to give customers more choice and let them build these open, high-performance AI networks that don't lock them into a single vendor. What Cisco's doing here is actually brilliant. It's a two-pronged strategy. So for their customers who are already invested in Cisco's own Silicon One hardware, they can just license the Spectrum-X features as a software upgrade. But for those who want a purpose-built ground-up solution, Cisco is also building switches directly on top of NVIDIA silicon. It's all about giving their customers options. And for you, the customer, this means incredible flexibility. You get to choose the silicon that makes the most sense for you, but you still get to standardize on a single, consistent AI networking platform. You can manage everything. Doesn't matter if it's running on Cisco or NVIDIA hardware, all from one single pane of glass, the Cisco Nexus dashboard. And if you're doing a massive deployment, this gives you crucial supply chain diversity. But this partnership, it's about so much more than just silicon. It's about taking this incredibly complex, powerful technology and making it simple enough for any enterprise to actually use, not just the cloud giants who have these massive teams of engineers. And this is the result, Cisco Nexus Hyperfabric AI. You should really think of this as the easy button for building an AI cluster. It's a complete, turnkey solution that integrates the compute, the storage, and this new AI fabric into a single package that's managed from the cloud. It takes all the guesswork out of building your own AI factory.
And the early feedback has been amazing. Take Wake Forest University. They're highlighting how this simplified approach is going to significantly accelerate their research. This is really about democratizing access to world-class AI infrastructure for everyone.
And it's not just in academia. AI companies like Sharon AI see this turnkey solution as the key to simplifying their deployments, which lets them build out their AI factories and power sovereign AI initiatives way, way faster. So, how do they do it? How do they make it so simple? Well, they're turning a process that used to take months into just a few weeks. You can literally design your entire fabric with a single click, using a pre-validated template. Then the system automatically generates all the complex cabling layouts. You can throw away those spreadsheets. And when it's time to actually rack and stack it, a guided on-site interface walks your team through every single connection. It's a total game changer for operations. So when you put all of this together, this new fabric technology, the huge industry partnerships, the simplified solutions for enterprises, it all points to a really fundamental shift in how we even think about the data center itself. And this right here is the single most important idea to take away from all of this. For decades, we have lived in a compute-centric world where the network was just plumbing. We have now officially entered a fabric-centric era. In the age of AI, the network is no longer a passive utility. It is an active, intelligent fabric that's every bit as critical to performance as the GPU itself. In short, the network has become part of the computer. So let's just recap the three big takeaways. First, in the AI era, the network is not just plumbing anymore. It's an intelligent AI fabric that is critical for performance. Second, these new end-to-end platforms that co-design every single component, that's the new standard. And third, operational simplicity is the key that will finally unlock the power of AI for every enterprise, not just the big guys. Which really just leaves us with one last fascinating question to think about. Now that we've transformed the network from just a set of dumb pipes into an intelligent, thinking part of the computer itself, what new, incredible things are we all going to be able to create?